Welcome to the integration of 1 over x to the power 4 plus 1 dx. This one is a complicated question for integration. It involves a lot of ways you can. There are many ways you can do it, but I have my own way. If you have your ways, please show me in the comments because there are many ways of solving the question. But I'll explain to you why I decide to take my way and how I doing my way. Now, in my way is first step, let's divide. So step 1, divide the numerator and denominator by x squared. Right. So I'm going to divide both numerator and denominator x squared. I am doing nothing, but I'm doing something. In other words, I'm saying 1 over x squared or over x to the power 4 over x squared plus 1 over x squared. So can further be simplified as I is equals to the square root of 1 over x squared or over x squared plus 1 over x squared dx. If you look into this, the denominator can be, you can use completing the square. You got to complete the square. For the denominator, we can complete the square. Complete the square. We can complete the square on the denominator. How do we do it? Now, sometimes it's easy to say, okay, let's give a try on x plus 1 over x, like this, then you square. Then at the end, you're going to add what you don't get, okay, or subtract what is not there. So it's going to be x plus 1 over x multiplied by x plus 1 over x. I'm showing those who don't know which is going to be. Some people, they know it very well. X squared plus, that's going to be 1 plus 1, that's a 2, plus 1 over x squared, which is going to be x squared plus 1 over x squared plus a 2. But we are supposed to put minus a 2 here to take out the plus a 2. So definitely this way, x plus 1 over x squared minus a 2 is going to be our denominator for that. And do you know that this denominator can also be represented by, let me put green so that you can see the difference. It's x minus 1 over x, right, squared, which is going to be x plus 1 over x bracket x plus 1 over x to give you x squared. Now, oh, there's a minus, sorry. It was supposed to be minus. So to give you a minus 2 here, then a plus 1 over x squared, then we are going to say it's going to be x squared plus 1 over x squared minus 2. Then we are adding a plus 2. So for this case here, so this case can be written as x minus 1 over x squared plus a 2. So we have got two situations here we need, and we must keep it in mind. We need these two situations. Okay, Now, let's look back at your I is equals to the integral of 1 over x squared over x squared plus 1 over x squared dx. We have to introduce, so introduce a 2 by saying what? By saying a half multiplied by 2 will give you a 1. You'll see this. Why am I saying this? Because my integration is going to be integral of, I will put a half outside here, or a 2, a half actually, a half outside here. Then I will say a 2 over x squared all over the x squared plus 1 over x dx, which can be separated. We can separate, but you should know that a 2 over x squared can also be written as 1 over x squared plus 1 over x squared. We can represent it like that. So we are going to make two, two entities there, because now that is going to be, I is going to be a half integral of now 1 over x squared plus 1 over x squared all over x squared plus 1 over x squared. I forgot the square here. X squared, like this, dx. And this can be separated to, okay, I wanted to save space, but I'm not going to save space now. I'm just going to do it in a separated version now. So we can actually, before we separate, we introduce again, introduce a 1 minus 1, which is a 0. So we are introducing a plus 1 and a minus 1 in the system. So how do we do it then? How we do it then, we say the integral is going to be a half here, the integration of a x squared plus a 1 minus, plus again, a half, no, I'm used to a half squared, minus a 1. I don't know what I wrote here. It's 1 over x squared, okay, all over x squared plus 1 over x squared dx. Now, we separate like this. So how we separate, we are going to say the integration I of this is going to be, we separate this as 1 over x squared plus 1 or over x squared plus 1 over x squared dx plus the integral of 1 over x squared minus 1 over x squared plus 1 over x squared dx, like this. That's how we separate it. Now we can rewrite this again to become a half the integral of 1 plus 1 over x squared all over x squared plus 1 over x squared dx minus a half here, integral 1 minus 1 over x squared all over x squared plus 1 over x squared dx. Now from there, now if we have our integration like this, let's choose. So to choose the denominators, let's write all the denominator we have. Remember that x squared plus 1 over x squared can be written as, right, the first one we have was actually x plus, so was a bracket, x plus 1 over x squared, and it's a minus 2. Is it a minus 2 or a plus 2? Minus 2. And the other one was x minus 1 over x squared plus 2. Now, with these things, we can choose. Let's say, let u be equals to, so we are going to use the u substitution equals to one of these, but we look at the numerator. So we are basically saying let u, and we look here, and we choose, and we also look here, we choose. For the first u, I will look here and say let u be equals to x plus 1 over x. So if I differentiate du over dx, I get a 1 minus 1 over x squared. Now this can be be shown on x of, you can actually see this part here is identical to this part here for this one here. So in other words, my du is equals to bracket 1 minus 1 over x squared bracket dx. That is exactly that part there. The other part is going to be, if we choose this part here, we are going to say let u be equals to x minus 1 over x. So du over dx is equals to 1 plus, because we take it down, 1 over x squared. That is to say, the du is equals to bracket 1 plus 1 over x squared dx. So this part is going to be this part here. So the colors are working well because it can show you better. Now I discover that if I say u, it's going to be a problem. So I have to define my first u. The green one is u1. That has a plus here. And the pink one is a u2. That is a negative here. So now, when I'm writing back, my integration is going to be a half the integral of. Now, this top one is a du2 all over. Now, if you look at the bottom there, I haven't even put I am supposed to put this in here. And I'm supposed to put the same thing in here. I'm supposed to put this one here. I think you understand. So maybe before we do that, let's put back the things that we're supposed to put. So I will erase here and now put the denominator in the expansion form or in the factorized form. I is equals to a half the integral of 1 plus 1 over x squared all over bracket x minus a 1x squared plus a 2, right, dx, minus a half the integral of 1 minus 1 over x squared dx all over, now I have to put the other one, it's x plus 1 over x all squared, then it's a minus 2. Yes, then it makes sense. Now we are going to say your I now, because we have defined the u already, we are going to say your I integration is equals to a half the integral of remember the top is a du. From what I showed you, or I will show you here because it's now clear, the pink one is going to go minus, so this one is going to go here. And the green one is going to be the other one, which is going to be going on the first one here. I think you're following the lines. Then let me write it down. So all over du, since it's the green, it's a du1, right? Which is a u1 squared plus a 2. Now, minus a half, the integral of du2 over u2 squared minus a 2, like this. So basically, this is, so the first one is easy, is because it's going to be a special integration that you look in the parameters, in the identities of integration. You will discover that the first part is going to be a half multiplied by 1 over root 2. And it's going to be arctan of what? Of u over root 2. Then it's going to be minus the second one. The second one is going to be a half multiplied by 1 over 2 root 2, and it's going to be the natural logarithm of u minus root 2 all over u plus root 2 plus a k. So this is that. But remember that, okay, I forgot to say root u1 and u2 here. u2, u1, u2, u1, 2. Okay, I forgot that. u1 and u2. Now, we are going to substitute our u's now. Remember that our u1, remember that we said our u1 is x plus 1 over root 2, 1 over x, and our u2 is that. So our final answer I, when we replace back our u's, is a 2 root 2 arctan, I like writing arctan like this, of what? Of x plus 1 over x all over root 2 minus 1 over 4 root 2 natural logarithm of x plus 1 over x minus root 2 all over this is u2 again, x plus u2 x minus, is it x minus, u2 is x minus, sorry, it's x minus here, x minus 1 over x plus root 2, right, all plus k. So this is the final integration of that question. Please like and subscribe to the page. More complicated mathematics I will show, and yes, you must subscribe there. Thank you very much.